The last tab in the Resource Monitor is the Network tab. With the Network tab, I can view every process that has network activity ongoing. So it's a real-time tab just like all the others. A few things we notice here. If we look at the right side of the screen, you see these TCP connections. This chart right now says 0 to 10. I look to have about 4 connections or so in that list, I would estimate. I can also see all the processes with network activity. So I have a couple of SVC hosts showing up, actually 3 of those. I have 2 OneDrive accounts on this machine, so they on and off generate activity whenever they synchronize. What I can also see, under TCP connections, I can see every connection I have. So I can see the remote IP address it connects to. So from here, I can tell that OneDrive is connecting to this IP address, the 104.208.28.54 is the remote IP address. I can see it's using port 443, and I can also see there's no packet loss and no latency on that connection. Well, we won't say no latency, low latency, under 100 milliseconds. So no packet loss and pretty low latency. To make this a little more dynamic, I'm going to open Internet Explorer and I'm going to go to ESPN.com. That'll take that a moment to open. But notice that 0 to 10 on the right side of the screen, that's going to change in a minute. And if you look at the TCP connections, this slide bar had very few things in it a moment ago. Now I have all of these connections through Internet Explorer. Now what we can do to give this a better view, I'm going to go back to the top and I'm going to filter this just so I'm looking at Internet Explorer.exe events. So when I go down to the TCP connections, everything in this list is just Internet Explorer. So that's a lot of connections, and they're all only Internet Explorer connections. Now, the reason for that, websites like news websites or sports like ESPN, they have a lot of things built into those sites. So icons for Facebook, Twitter, LinkedIn, the things embedded in the page like weather reports and other things are all their own websites that happen to be loaded into that view. But they all have to be connected to, they all have to be resolved. And there's always a lot of analytical stuff in those types of sites. So it is surprising how many connections some of these websites actually launch. To add on to that experiment, I'm going to open 2 more tabs here. In one, I'm just going to type CNN.com. Now, to be politically neutral, I'm also going to type in Fox News. Now, we don't care about the news, but those sites generate massive amounts of traffic with all the things loaded on the site. So you see my TCP connections 0 to 100. That's going to shift again in a moment. And I'm still filtering Internet Explorer traffic. So I'm going to just click these other tabs here. But notice that chart went from 0 to 100 to 0 to 500. Now, most of ESPN has loaded and gone dormant. So really what we're seeing here in this 0 to 500 chart is the CNN and Fox News websites. They generate an immense amount of traffic. If I look at the TCP connections again, all these are just Internet Explorer connections off those few websites. And again, we see the packet loss and latency. Packet loss normally means a connection is saturated, somewhere between you and the destination, or you and that remote address. Something saturated. So saturated, traffic has to be discarded and dropped off the network. Latency means there's a delay. Now, there's always some delay in a response, but latency is just a delay measured in milliseconds between your machine and the remote address you're actually connecting to. Anything under 100 milliseconds is considered incredibly fast. I'm at 50, well, a few 40s, actually a few 30s. So 30 to 101. All those connections are very fast connections. So no concern about latency, and I have no packet loss at the moment. This is a very useful tool for troubleshooting any type of network-related issue. A real-world example when I would use this tool. If I have a user that were to call me after lunch and say, my connection to this application seems to be incredibly slow. Well, the user is in a branch office, and I know the application resides in our parent office. The user tells me this application was fine before lunch. I went to lunch, came back, now the connection's incredibly slow. Well, my first thought is, where do I begin? The user's computer could actually be slow. The network in the user's location could be slow. The WAN connection that connects the branch office to the parent office, that could be slow. The network in my parent office or the server itself could actually be slow. So many things could kind of give you the same issues. This would be the easiest, fastest way just to look at the network connections. If I look at this from a machine in the branch office connected to a server in the parent office, if I have zero packet loss and low latency, as my machine does now, I know it's not a problem with my provider's connection. It would be a resource problem, maybe on the server itself, but it would not be a network-related issue with packet loss non-existent and latency that low. So a very useful tool to quickly look at some of these types of settings.